All right, so all right, so greetings everyone. So in tonight's lesson, we'll be talking about laws of indices. All right. So not only just the laws of indices, but other algebraic rules that applies. Okay. So let us talk about the basic rules in indices or just algebra for that matter. All right, so the first thing I want to talk about is just basic simple rules that students really don't tend to follow. And these are things that I just want to establish a firm foundation on, even going forward with algebraic lessons. So just let us have something here now where we have a squared plus a. So this is just really a basic, just for basic information, as I said. So a squared plus a, if you look here, is that if you look carefully, that both of these are a's, right? And one of the things you must understand is that in algebra, these are what you call variables. This is just a variable. This is variable, right? These two are variables right here. But not only that these two are variables, not only that they are variables, but that the square right here is saying that this a is the base of the index 2. So the base of the index 2 is actually a. So variables, and even in understanding what variables really are, variables are really storage containers. Like just think of it like a box. Like I have a box and I give it the name A. So I'm going to give this one A, right? So in this box, the name of this box is A. Let's put it right here. Name is A. And inside the box holds a value. It could be any possible value. So this box could be called um, it's this called A and it holds a value of 2. So when I call upon A, when I say A squared is really 2 squared, right? If I were to have another box and I will give it another name, let's say that this box is actually Y. And in this box is 3. So if anywhere I go in algebra and I decide that y it represents 3, it means that if I say y cube, it also means 3 cube, right? If I say that, if I were to come now and say, for example, y, well, I already said that y is cube, but let us say I'm going to give this another name. So I'm going to say that this is x, right? So this is x, and I'm gonna give this to be I'm gonna say that this is 4, right? Now a is 2. If I were to have a here, which we know that that is 2, and I say a to the power of x, all I'm saying is 2 to the power of 4. And what does that give me? 2 to the power of 4 means 2 times 2 times 2 times 2. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 gives me 16. So it's really to understand variables and just understand that when I even talk about base, a base doesn't necessarily mean a variable, but variables are what you will have as your letters or they are symbols, right? And they are really, as I said, storage. They are storage containers. They hold any possible value. All right. So in understanding that, I just want to further explain the difference between variables and base. Is that if I were to have 2 squared, this 2 right here is not a variable, but it is the base. Just think about base as in the bottom number. So your base is really the bottom number. And here now is referred to as your index, also known as your powers also known as your exponents. So these are really key things to really know in algebra. So with that being said, let's truly get into what we're rules, laws, and so forth. So just a while ago, I had a squared. I'm just gonna put some other things in between, right? So I'm gonna say, for example, this is ax squared rather, and I'm gonna say this is a ax. All right. So here we have variables a and x. So a and x are two distinctive variables. And here we have x being squared. Now, the problem that students have in school, well, they make a lot of mistakes, but one of the basic fundamentals that I want to highlight tonight is that whenever I have like a and x squared, and I'm going to add another variable to it, I need to understand how I go about doing that. Now, a variable as a plus a. A plus a means that there's a number that is not seen. So that number is really 1. And there's one that is right here. This one right here is referred to as my coefficient. And that is just one only. If I say 2a, 2 would be my coefficient. If I say 3a, 2 is my coefficient. If I say 5x, x is my variable and 5 is the coefficient. So it's just to understand these things. And even looking at this small example right here in adding variables, we need to understand that adding variables in this form means that we are going to take this 1 and we're going to add it. So we're going to say 1 plus 1 is 2. And then for the variables, we're not going to do anything with the variables because, well, that is the rule. We just don't add them and we just write it as a. If we were going to add them, well, technically, but if you look at it like that, if you were to just look at it like that, adding them in this case means that you're adding the coefficient. And as I said, 1 plus 1 is 2. And you just rewrite the variable. Right? So for example, this, let us say, for example, that this a right here was 3. And if I say 1, I'm just saying 1 multiplied by 3. If I were to add and come again and I say, again, 1 multiplied by 3, I'm saying 1 times 3 is 3, and 1 times 3 is also 3. So that gives me 6. Let us say now, for example, if I had 2a plus, let's say 3a. If I were to do something more with my variables, let us see what we're saying right here. So if I say, so what I'm saying is that I add these two, which will give me 5, and then I rewrite the variables. Now, in rewriting our variables, I need us to understand how that really works. Again, say for example that this a was a value of maybe 2. Let's say that it is 2, right? Or let us call it as 4 because we don't want to mix up these numbers. So I'm going to say that a is 4. So 4 is here plus 3 in bracket 4. So 2 times 4 actually gives me 8. And 3 times 3 is actually 12, right? Now look at what we had there. Where we have the 2a, we said that the 2a plus 3a gives us 2 plus 3 is 5, and all that we did was to rewrite the variable. Now here's how this works. 8 plus 12 equals 20. Now look at the beauty of this. If we said that a is 4, like we did, and we're saying that 2a plus 3a, all I did is to add the coefficient and rewrite the variable. If I were to take that principle and to check if it really applies and it works, I should get back 20. Because when we put it in here, we can see that we got 20. So if 5a really means 5 multiplied by whatever value a is, and 5 times 4 gives us 20. So that is how it actually works. So that explains itself why we actually rewrite the variable and just add the coefficients. So that is basic rule. But there are cases that we have to be mindful of, as in a case such as this one. So this is ax squared plus ax. And if you look careful, as I was explaining before, is that this is x being squared. This one is not being squared. Now, in having this, we cannot actually add this. We can't add them. But instead, we can actually factorize. And the factorization is a topic by itself, which I will not really be going into in this lesson. However, if you want to learn about factorization, you can check out my other videos, right? But let us talk about this for now. So ax squared plus ax, right here, they cannot be added. And the reason is simple, is because this x squared right here, this x right here is being squared, and this x is also being squared. It's not being squared, but it is raised to the power of 1. So these two are not like terms. Now, what that takes us in identify what are like and unlike terms. So like terms in algebra, so I'm just gonna have something right here. So let us say 2x squared plus, I'm gonna say 3x. Like terms in algebra refers to two terms that have the same variables. So if x is right here, x also must be right here. So that's one criteria, same variables. So same variables, that's one criteria. Criteria two is that they must have the variables raised to the same index. So the variables raised to the same index. So the variables must be raised to the same index. That means that if this is x and this is x, in order for us to add them, these two must be x squared. Or the both of them would have to be x to the power of 1 in order for them to be added. If they are not the same index raised to the same power, then we cannot add or subtract variables, right? That is key for us to note, right? We cannot add or subtract terms if the variables, if there is unlike terms. Then and an unlike term is our terms that if we check the variables, we see that they are not the same if they are unlike. If they are also, if they have the same variables but the powers are raised to a different index, terms are also not considered as like terms. So two things that you must bear in mind. All right. So I think that we have really set the foundation. We have set the pace to get into much more. One of the things that I want to further explain is why is that a squared and a, why are they not like terms? All right, let us talk about that. You remember that we in fractions, remember in fractions well, if I say that, if I have, for example, 3 over 4, right? I cannot add 3 over 4 to 6 over 8. I can't add them. And the reason is because whenever I have two different denominators, they are classified as unlike fractions. The fractions, they are not like. They are unlike fractions. They are not the same, right? Although they are the same in value, right? So this literally is the same in value as this. This is actually an equivalent fraction to this. So although they are the same value, we cannot go ahead and add them. So we can't say that 3 plus 6 is 9 and then 4 plus 8 is 12. That would be really, really wrong. So we can't do that. So let us say, for argument's sake, so let us say that I'm going to say that if A here, if A equals 3/4, it means that A squared equals 3/4 being squared, which this actually means 3 squared over 4 squared. So this right here is going to be 9. And this over here is going to be 16. So if we're squaring this A, we're saying that we're actually saying, so a squared would be 9 over 16, and we're saying plus this a right here would be 3 over 4. So that in its basic understanding, you should get to understand why we can't add these, right? We could actually have the approach of simplifying it, but that is really in factorization. And as I said, if you want to learn about factorization, please check out my other videos, right? So a squared plus a, they are not classified as like terms, therefore they should just remain as they are, or simplified if you want to, if you understand how to simplify it, right? In simplifying it, it's just a way of factorizing where we would have something like this. So just giving you a basic idea. So we would just have that. That is how we simplify it, right? And again, if you want to learn about that, check my videos on factorization. Beautiful. So where are we? We are now at a very crucial point in the lesson. And what I want to emphasize now is just really the laws of indices. So rules that govern my indexes. So my index laws. So let us talk about law number one, which is fundamental. So if I have x squared, so we just talk about adding powers, right? And subtracting them, how we treat those, that if they have the same variables and the same variables raised to the same index, we just rewrite the variable and just add the coefficient. Now, in this case, now we're going to talk about multiplication of our variables. So let us say now we have x squared and x cubed. Now, whenever we have the same base, remember that this is my variable, but it is the base value of this squared number. So this is my base, so this is x squared. So the base is x, right? So x squared, and we also have x cubed. Now the rule is that if we look now, we are multiplying, and though the index are different, our multiplication, this the like and unlike terms does not affect multiplication or division, right? But instead, where we have x squared here, the rule is that whenever I have the same base, I'm going to rewrite the base. So that's the first principle. And then for our index, we actually add them. So we add a 2 and a 3, which gives us 5. So x squared multiplied by x cubed gives us x to the power of 5, right? The next thing that we have to understand now is that this is x to the power of 5. And this is just that. That is correct. And if we look here now, we could also have x to the power of 5 being divided by x to the power of 3. The rule is the same. If we're multiplication or division, this applies to both. Addition and subtraction have their own rules. So when you have the same base, we just rewrite the base, we subtract the index. 5 minus 3 gives us 2. That 2 is correct, right? So looking at that example should be clear even in explaining it, but I'm sure that it would be a wonderful thing if I give you the whys on how things work. And that is really the purpose for this lesson. So I'm going to say, for example, that x is 3. Let's just say just x is 3. So every time we see x, the variable x, we're just going to say that it is 3. So here, if we say that x, so if we say that x is 3, so x equals 3. So x being 3, it means that we're saying here 3 squared multiplied by 3 cubed. The rule is that if the base are the same, we just rewrite it and then we add the powers. 2 plus 3, that's going to give me 5. Right? So that is fine. Now let us look further now. Suppose we're given the scenario of explaining this. Suppose we're given that someone throws a question and says, but how do you get, or how does this make sense? Let us talk about how it makes sense. 3 squared means 3 times 3, which 3 times 3 is 9. We also have, so we have times 3 cubed, but really means 3 multiplied by 3. 3 times 3 is 9. 9 times 3, that's 27. That's 27. Now, if we were to multiply these, it will actually give us 3 to the power of 5. How do I know that? Now, we can actually take our calculators and we can really zoom into that, right? So if I were to say 3, so hope you can see it very well, just making sure, there we have it, right there in the camera. Right, so 3 to the power of 5 gives me 243. So this right here gives me 243, right? So that is that. Now we're going to test this one now and see what does it give me. So let's test it now. So we have 9 times 27. So that's 9 times 27 right there. Also gives me 243. So we can see therefore that the rule actually applies and it works perfectly. If we were to try the one for the division, we can see it actually works very well just the same. Let's go ahead and do that one. Right, so let me go ahead and do that one. So we have, so the division, so again, x is going to be 3. So if I have 3 to the power of 5 being divided by, again, 3 to the power of 3. All right, so this one is a little bit easier, and you're going to see why. The rule is that I keep at the base, just 3, and then subtract the index. So 5 minus 3, that's 2. And we know that 3 squared means 3 times 3, and 3 times 3 gives us 9, right? So we know that. So with having that understanding then, is that we can actually go ahead and use that now and just see how it works. So 3 to the power of 5 means 3 times 3 times 3 times 3 times 3. 1, 2, 3, 4, 5. And then this now we are saying divided. So we could put the division sign here, or we could just have it being under it like that. So we could say that 3 times 3 times 3. So these are being canceled out. And I'm left with 3 times 3. And 3 times 3, of course, is the same as 3 squared. And 3 squared gives us 9. So beautiful. That actually, it really proves itself simply right here. All right, so that is just one aspect that I wanted to touch. Now let us touch another aspect where we have 2x squared multiplied by 3x, right? So here now is that if we look here is that these two have the same index, right? This 2 to the power of 1 has the same index. If it was 2 squared and this is, we could actually still work them out, but let's just have it like that, right? So here now is another simple thing, is that if you look, the variables are still the same. So they are the same, but we have coefficients. Now we could say it simply now 2 times 3, that's going to give us 6. But when it comes down to the variables, we are going to rewrite the variable, and then this is x to the power of 1. We just add 2 plus 1 is 3. So that answer is just simply 6 to the power of 6, x to the power of 3. That's the simple answer, right? So don't be confused with these. These are not the variables. The variables are just the letters or the symbols, right? So just have that part down. So that's about 5 different rules, or really some, it's a 5 different ways of explaining multiplication and or division of our index. So those are just some basic things to bear in mind. Now, here's something that I want to really go onto, right? So for example, if I ever have a case or a scenario such as a squared, or let us use x since we're talking about x, and I want to say multiply this by y to the power of 4. Same is true. So for example, if I want to have x to the power of 5 being divided by y to the power of maybe the same 4. What should I do in such a case? All right. So in this case, we can't do anything because the variables are not the same. And because they are not the same, we're just going to multiply x and y. We're just going to have them, and we're not going to add the power. We're not going to add these powers. We're not going to add them. Instead, we're just going to rewrite it. So all that we did was just to rewrite it. We did not do anything there, and that is the correct approach. Here is the same thing, right? We're not doing anything. We're just going to have it as x to the power of 5 over y to the power of 4. So in cases where the variables are different, do not do any form of multiplication or addition. Sorry, not any, don't do any form of multiplication and division. So because we're talking about multiplication and division. The same is true, of course, if you're adding or subtracting, like what we said earlier, right? To explain that, let me just erase this one, and just to explain that, I'm sure you will not get the bottom one if I just do the top one. So, for example, know that this now is 3. So, say for example, the x is 3. So we have, and the y, for example, is a 2. So x would say saying 3 squared multiplied by the y is 2, so that's what 2 to the power of 4, right? The correct thing to do is understanding PEMDAS order of operation is that we have to just evaluate this first. Since in the word PEMDAS, if you see here, exponents are calculated, um, exponents are calculated before we do any form of multiplication, right? So we cannot do any form of calculation um, as it relates to these two when multiplication is being done. So here now we have a 3 and the 2 right here. When you're multiplying them, we can't do anything. We just have to evaluate this first, and then we evaluate this, and then know our multiplication here. What is PEMDAS? PEMDAS refers to parentheses, that would be your brackets. E stands for exponents, M is for multiplication, D is for division, A is for addition, and S is for subtraction. Right? So in the order, x squared is actually done before multiplication, division, addition, or subtraction. So what am I saying? I'm simply saying that in working out these two, we would have to evaluate x squared first, and then we evaluate y squared, sorry, y to the power of 4 before we can do any form of multiplication. So if we were to try, if we were even to try it, just think about it for a moment. If I were to say 3 times 2 equals 6, and then maybe add the index, 2 plus 4 is actually 6. If you were to take out your calculators and try that, you will see that what you will get is totally different from having 3 squared is actually 3 times 3, which is actually 9. Let me just have an indication. So this is actually 9. And this now would be what? So we have that being multiplied. So 2 to the power of 4 means 2 times 2 times 2 times 2. 2 twos is 4, 4 twos is 8, 8 twos is 16, right? So 16 would be right there. So 9 times 16, if we were to multiply 9 times 16, right, that should give us 144, right? So multiplying it, 16 by 9, 9 fives 54, 9 ones 9, and then plus the 5 gives us 14. So we have 144. So you just have to understand that this right here, 144, does not equal 6 to the power of 6, does not equal. And just to even to prove that, just to prove that 6 power 6 actually gives us a different number. All right? So it's something totally different. All right. So in wrapping up this tonight's lesson, there's something that I really need to do to complete our lesson. And there is just one more thing. If you remember that what we just did, then this is going to interest you. So this one now we're going to be talking about the same three, or we could just use the same x and y for this matter and multiply by y. But in this time, we're going to have x being squared and the y also being squared, right? So we could also have the same x to the power of 5, well, x to the power of 3 rather, divided by x to the power of 3. Now here's a thing though. In this case, the variables are different, but you'll see that the index are the same. In a rule such as this, we could combine the x and the y and then bracket it and just rewrite. Note I'm not adding, I'm rewriting the squared. So these are not going to be added as in our first example, right? And now all that we're doing, we are multiplying, we are combining these two together and then having it being squared. The same is true that can be done here. We could combine x over y and just rewrite our cube right here. Let's look at that. All right, so x squared, let's say for example that x again is 3, and we're saying c squared multiplied by, let's say that y is 2, we're saying that that is being squared. So if the rule is that we can multiply these two, which will give us 6, and then rewrite the 2. So let us evaluate again now using the order of operations. 3 squared means 3 multiplied by itself, which actually equals 9. And 2 squared is going to give us 4. So if you look carefully, that 9 times 4 gives us 36. But if we look at our rule, we also get that 6 squared is also 36. So that really, really works. So the other part that I want to do now is with the division. Let us look at the division of how that works as well. So again, I'm going to choose different numbers for the x and the y values. So I'm going to say that x is 4. So I'm going to say that x is 4 in this case. So we're going to say that y is 2. All right. So we actually have 4 cubed divided by 2 cubed. So the rule is that we just simply combine them as 4 over 2, and then in bracket I just keep back the root, the power, the index. So we could just simply parentheses first. Remember PEMDAS, these with brackets are parentheses first, so we could just simply work that out. So this would just be 2. So all I'm left with now is 2 to the power. Well, I just want to put that right here. 2 to the power of 3. And 2 to the power of 3 actually gives us 8. Right? So 2 to the power of 3 means 2 times 2 times 2. 2 twos is 4, 4 twos is 8. Here, 4 to the power of 3 gives us 12. And 2 to the power of 3 gives us what? Well, we have it right here. It actually gives us 8. Oh, sorry. I literally just multiplied 4 and 3 together. Sorry about that. So it's going to give us 64. And this now is going to give us 8. So 64 divided by 8 gives me 8. Lovely. So that really, in a nutshell, really talk is really based of just some basic rules in algebra that I really wanted to expound upon even tonight's lesson. I will definitely be continuing on Wednesdays and Thursdays um, at 8:30 p.m. You know, well, that time is really in Jamaica time. That's where I'm from, the Caribbean. So that time I'll be having my YouTube lives. Also on TikTok, I also host lives there from Mondays and Tuesdays at the same time, 8:30. All right. Thank you very much for tuning into this lesson. Please remember to like, share, and subscribe to this video. And I truly would like to have you back with us again. All right. Until again, thank you and take care.